you can use these HTTP methods from any tool like CI/CD tool or configuration management tools, or even you can use this in the browser. There are some URLs you can um, create, and you just want to give management, tenant monitoring, and servers. You will get the details like this. So without logging into admin console, you can direct provide the URL, admin port, and this context. So you will get the status of all the WebLogic resources in JSON format. So this is what we discussed in the last session. So I have created a cluster and applications, all this, all the data you'll get. So data source, if there is a data source, you'll get the information. And yes, if you provide the manage server name under the servers, you'll get lots of data. Like, you'll get the memory percentage, you'll get Java version, OS. So why this feature is provided is to support, automation, or you can do scripting. You can extract the data without, any GUI or manual intervention, human intervention. You can use. There are different uh, methods you can use, but yeah, uh, this would be enough, I guess, because we are not going into automation and all. Just to know, apart from admin console, there is one more feature that you can utilize to monitor and manage. So in order to manage, you will use the scripting, or Ansible or Chef, or those kinds of configuration management tools. So this is what we discussed. And today we will start OHS. Just like IHS in WebSphere, OHS is Oracle HTTP server. It is a web server based on Apache 2.4, which is highly stable and widely used web server. So it is an open source. Apache is an open source, not OHS, and it is tightly integrated with Oracle Fusion middleware products like WebLogic, Sovasi, OBIE, and there are many other tools, many other products with which OHS can be integrated. So we will see all the key features and core components. So first we'll understand what is a reverse proxy and how it works, and why to use a reverse proxy in an architecture in production environments. What is the use and what are the features it provides with? And yes, we'll understand how SSO works with a real-time example, because in enterprise applications or enterprise environment, uh, SSO is used a lot. And we will understand the core components like the modules, right? Apache works on modular architecture. So whatever the modules are required, you can load only those modules. You can restrict the modules that you are not using in order to reduce the burden on the Apache engine. And few configuration files we can use, and how exactly the Apache engine works. It uses MPM. We'll understand the different types of MPMs and when to use which MPM. And yeah, yes, in real time, you will install OHS in different methods. There are two methods. One is GUI, like normally how we install WebLogic, and the other one is silent installation, mostly used in no GUI environments. It will be command line. You can also use scripts or CI/CD to you know install this in silent mode. Finally, we'll understand the directory structure and yeah, summary of what we discuss in this lecture. So to start with, OHS is a web server and it has got all the features that is provided by Apache HTTP server. Why? Because OHS and IHS are based on Apache HTTP server. So both the vendors, IBM and Oracle, what they did, they have, as Apache is an open source uh, web server, they have customized the Apache source code and they have added few features that is compatible with integrations of their own products. The same way IHS, right? So this one, OHS, it acts as a reverse proxy and it provides SSL termination and it can be used as a load balancer and it supports URL rewriting and SSO single sign-on and security filtering for all the web tier applications. So we'll discuss each term and the significance of each mechanism in OHS. So to start with, what is reverse proxy? A reverse proxy is a server that sits between clients and backend servers. What it does, it forwards the client request to appropriate backend server, and then the response will be returned to the same client. So how it works? Client, mostly the browser or any API service, sends the HTTP request. So it may be any URL that is first that hits the reverse proxy. It may be OHS or Nginx or Apache. These all are reverse proxies. It sits, the reverse proxy component, it sits between the client and the backend server. So all the requests, HTTP or HTTPS requests or API requests will first hit the reverse proxy. The reverse proxy forwards the request to the backend application servers based on the context root that is configured under appropriate configuration file. So generically speaking, you can configure the this configuration like the request routing information of backend servers on httpd.conf file, or else it depends. Like in WebSphere, that will be configured under plugin configuration.xml, and in OHS there are different methods. You can configure it under httpd, or else there is one more configuration file that integrates with WebLogic, which is mod wlohs.conf. And there is also one more method, like you can create um, configuration files based on application. So if your OHS is acting as a reverse proxy and has got multiple backend servers and multiple applications deployed on different application servers, you can create each, you can create a single configuration file for each application and place it under a folder, and you can load that folder into httpd.conf. So that is also there. So we'll discuss in this OHS classes. So once the request is forwarded to the backend server based on the context root in the configuration file, and whatever the processing done by the backend server, the response, the executed response will be sent back to the reverse proxy the, in the form of HTML or JSON for APIs. So once the reverse proxy receives the response, it will render and send it back to the client. The response is sent back to the client. So this is what a reverse proxy does. And your application server, WebLogic, Jboss, WebSphere, or Tomcat, these servers have the capability of directly receiving the HTTP request and can process the static content and also the dynamic content. Then what is the use? What is the necessity of a reverse proxy in between client and backend server? So reverse proxy provides with security. First thing, security. What it does, it hides the backend servers from direct exposure to the client, reducing the attacks, cyber attacks. So the first thing is security. The second thing, uh, load balancing. So the load balancing, if you want to balance the load or workload management or failover mechanism, so you need to use a reverse proxy. So it distributes the traffic across multiple backend servers for high availability and failover mechanisms. And it provides with caching feature also. So what we do, we usually deploy the static content on HTTP servers. So these web servers, they store the static content to improve speed and reduce the backend load. So how do they store the static content? They do caching. So there are different mechanisms. Again, there are different procedures to cache the uh, stored the static content, right? So we have seen in uh, WebSphere there is a dynamic caching service which is used to optimize uh, and provide the better performance without doing the rework, re-execution of the request. So caching improves the performance actually. And SSL termination, it handles HTTPS encryption. So what happens when you do the SSL configuration on the reverse proxy and you don't do it on backend servers? The burden of HTTPS encryption and decryption will be reduced on the backend servers. So we know what is a SSL handshake, right? Whenever an HTTPS request is hit to the web server sends the SSL certificates, root, create the chain, the certificate bundle to the client, and the client authenticates it, validates it, then it will start the encryption process. So the encryption and decryption process is called SSL termination. So this is handled by web servers. So if this is SSL termination is handled by the web servers, it automatically reduces the burden on the backend servers. So you are reducing the burden on the backend servers by using SSL termination, caching of static content, and yeah, these two. And there is compression. It compresses the responses before sending them to the clients to save the bandwidth, network bandwidth. So if the usual response is 1 MB, the OHS compresses it and it will be like 500 KB. So there the bandwidth is getting reduced. URL rewriting is another feature and it modifies the client requests before passing them to the backend servers. So why this URL rewriting is required, we will see that once we get to the core concepts. So everything explained why to use the main features are security to hide your backend servers, load balancing for workload management, um, and traffic distribution across multiple backend servers for high availability. Caching serves the static content from the cache. SSL termination, it handles the encryption, offloads the SSL from the backend. So it offloads the SSL termination from the backend. So only the web server handles the SSL termination. Compression, uh, it improves the bandwidth efficiency, and URL rewriting modifies request URL and supports clean routing or redirects to the appropriate backend servers. So these are the key features of a reverse proxy. And now the key features of OHS. So the feature is Oracle Fusion Middleware integration. It provides seamless connection with WebLogic server, Oracle, identity management. So what is identity management? It's a product, Oracle's product, um, where you can create the identities, the users and groups and all. So it can be integrated. OHS can be integrated with Oracle Identity Management for users and groups credentials and WebLogic servers. And it provides with enterprise security, like your enterprise application requires SSL, client authentication, and also SSO, single sign-on. So single sign-on can be provided with the help of another Oracle tool called Oracle Access Manager. So this provides the SSO tokens to the client so that the single sign-on token can be used to access different services without any credentials, logging in again and again to access different applications. So that uh, facility feature is also provided with OHS. And reverse proxy and load balancing can be achieved using mod proxy, mod WebLogic, and mod WL OHS. So these are the modules. Mod proxy is an Apache module. So it is common, generic, and mod WebLogic and mod WL OHS. These two are WebLogic specific modules. Just like, in IHS, you will load WAS app 22 or WAS app 24 module. So that module
Yes.
helps integration with IBM WebSphere application servers. So OHS also supports the feature which is modular architecture. Okay, so Apache works with modular architecture. What does this mean? It means you might have seen in HTTP conf file. So you will see lots of load module. You can load logging module, you can load SSL, you can load caching. So there are different modules that is provided for load balancing or mod proxy, mod JK support, mod cluster. So there are these all are different modules. So OHS supports both the modules. There are two types of modules that OHS supports. One is generic modules that ships with Apache, like mod proxy. This is to proxy the request to the backend application servers. And Oracle custom modules like mod WL OHS. So this helps to integrate OHS with Oracle Fusion Middleware products, right? So this is modular architecture. If you don't want to use this one, okay, fine. You can also integrate only Apache web server uh, with the WebLogic servers without using OHS, because OHS is a licensed tool. And in terms of performance and scalability, OHS uses and supports MPM, which is event thread models and caching. We will understand what is MPM, is multi-processing methods, modes. For monitoring and diagnostics, usually we know all the web servers has got OHS log files, and along with this, you can also monitor the real-time metrics using Oracle Enterprise Manager. So we haven't seen this Oracle Enterprise Manager in WebLogic. Why? Because we used generic installer. We haven't used the Oracle Fusion middleware infrastructure because that is used for multiple integrations, multi-tenancy, right? So if you remember, we discussed JRF, non-JRF domains, multi-tenancy support,
Yeah,
integration
yeah.
of SOA. Yeah. So
Mm.
you can monitor the live performance metrics of OHS from Oracle using Oracle Enterprise Manager and DMS metrics. This is diagnostic monitoring service. So this one is used, DMS service is actually an application that integrates, that collects the data from the JMX, and it will be displayed on Enterprise Manager console and cloud and DevOps ready. Okay, it can be containerized. Which one? OHS, and it can be used in OCI cloud with automation via WLST scripting, and you can also use Enterprise Manager. So OHS has lots of features. It provides you with lots of features where you can use for integrations, for security, for load balancing, for modular architecture, and performance and scalability based on the type of uh, applications you are working on, and monitoring and diagnostics made easy with Enterprise Manager and DMS services. And in the cloud native environments, it can be containerized and used it in the OCI, which is Oracle Cloud Infrastructure. You can do automation using WLST and shell scripting or Bash. And also you can use Enterprise Manager for managing your OHS configuration and yes, mapping the uh, applications or modules or whatever. So management, monitoring, and performance, security, integration, everything is provided. So how SSO works on OHS? So it's all about security. The first thing uh, when it comes to the front end or the client-facing servers. So these days, load balancers are playing a crucial role, which faces client, client-facing server as client-facing server. But in fewer environments, there is OHS or IHS or Apache or Nginx works as a reverse proxy. And whatever a load balancer can do, HTTP server does more than that because the load balancer cannot process the static content, but your web server does that. So if we want to understand the mechanism, how the single sign-on work, not only on OHS, but usually, let us say there is an enterprise environment, enterprise application wherein um multiple web applications are available in the backend or deployed on the backend servers. So user wants to access this application, HR portal. So here there is another product, OHS WebGate. It intercepts the request and redirects it to OAM login page. What is OAM? It is Oracle Access Manager. So this one is an LDAP and it provides with a single sign-on tokens. So user authenticates first via OAM login. So it is Active Directory or LDAP, etc. So once the user authenticates with the proper credentials, OAM issues an SSO token. Like example, OAM authentication cookie. So this cookie is validated by OHS and it sets the header to the request in the request as remote user. So once it is set and forwards the request to the backend WebLogic server, all the subsequent requests by this user to access different applications will use the SSO token by bypassing the login again and again for different application access. So this is a simple architecture. Let us understand in a sequence diagram. So what happens when a user requests a web resource like HR portal? The request hits the Oracle HTTP server where the WebGate is integrated. So once the request is hit, the request is redirected to Oracle Access Manager login page and user logs in with the credentials on the login page. Once the credentials are authenticated, then Oracle Access Manager sends a SSO token to the user, and the user will retry accessing the HR portal with the SSO token. And this token is validated again by Oracle Access Manager, which is installed on a server, and this is OAM server. So the token, if the token is valid, then the request forwarding with remote user header will be sent to WebLogic server, because different applications are deployed on your WebLogic backend application servers. So when the user's request is appended with remote user header, then it means it has got a valid SSO token and it has a ticket to access all the different applications without any login. So the forwarded request is processed by your WebLogic server, and the response is sent back to the OHS. Why it is sent back to the OHS, not directly to the client? Because OHS is acting as a reverse proxy. So whatever it sends to the backend, it receives the response and it will render the response into proper uh, format and compresses whatever the you know the features it has to apply. Everything will be applied and the request is sent back to the browser or client, and the browser will render the response into HTML format for human readable or human understanding format. So this is how this single sign-on works. The same with you know, WebSphere also. If you integrate an LDAP, you can use the SSO mechanism. There, it will generate the LTPA tokens, lightweight third-party access tokens, right? So the token can be copied to different application servers as well to bypass the authentication mechanism. So in a real-time example, if you want to understand the same concept, Oracle works as a reverse proxy in this example, OAM as a single sign-on provider, multiple web applications deployed like finance, HR, and CRM. SSO flow, how the flow will be. So user hits the URL for HR portal and the domain name portal.company.com. So OHS with WebGate, what it does, it redirects the user to the login page of the company, right? Here, login page. So this login page is on OAM server. User logs in with the valid credentials. Then it is authenticated by OAM and it issues the SSO cookie, just like LTPA cookie in WebSphere. And user will be redirected back to HR, this application. Now the request includes the cookie, SSO cookie. OHS validates and forwards to WebLogic with user identity, adding remote user in the request header. So once the request header contains this flag remote user in the request header, it means that user can access different applications like finance or CRM without login. So this is the entire flow in a real-time environment like enterprise applications. So you will get token for any one application access with a proper login credentials, and your request header will be added with remote user flag once the cookie is authenticated, and all the subsequent requests that is accessed by the user, that is sent by the user to access different applications, will not prompt for login again and again. So this page, if you hit finance here, it will not go to login page. You can directly access. So talking about the core components of OHS, there is mod WL OHS. It is a Oracle module for proxying requests to backend WebLogic servers. So just like mod JK in Jboss environments and Tomcat environments. Mod JK is a module that proxies the requests for high availability in high availability environments. It is a mechanism used for load balancing and workload management. So the same module, but Oracle specific, Oracle WebLogic specific module. Module WebLogic OHS. So this is an integration between OHS and WebLogic. And there is mod SSL. It handles the HTTPS and certificate validation. And mod proxy HTTP, and mod proxy AJP. These all are generic modules. Generic modules in the sense it is used by Apache. You can find these modules in Apache as well. Mod SSL as well. So these are used for load balancing and backend communication. And mod OC4J, this is older a very older module. I think this was in Oracle 10G or before that, and it is deprecated in the newer versions used in legacy Oracle app servers. So it is not used because new modules has come up with lots of enhancements and better performing modules. And mod PLSQL for accessing Oracle DB through PLSQL web gateways and configuration files like HTTPD. This is a primary configuration file. The web server looks for when you start the engine, Apache engine. So the first file, the first configuration file it loads is httpd.conf. And in this httpd.conf, there will be references for other configuration files like ssl.conf or dms.conf or wlproxy.conf or else modwlohs.conf. So this will have the references. With those references, it will load the appropriate uh, feature that is required. Whenever your request needs to access the other resources, it will get the reference from HTTPD. For example, if it wants to communicate with the encrypted communication, then it will connect with ssl.conf and fetch for the certificate and also the protocols defined in ssl.conf, right? So all these are managed with the help of modular architecture. So if you don't want mod proxy AJP, yes, you just comment it out in the httpd.conf. It will stop. It will not load this component or module. If you're not using load balancing, you're just using the no, you're just using the OHS to proxy the request. Then mod WL OHS, which comes by default, is enough. You don't have to load this specifically. You can comment it or you can remove it from the httpd.conf, right? So these are the core components of OHS. So earlier we discussed key features of OHS and features of reverse proxy and components involved in OHS, right? So mostly we will work with mod WLOHS, mod SSL, uh, what else? httpd.conf, ssl.conf, and there are some other. We will also use log files and yes, there is a different architecture. We cannot compare OHS with IHS because when you work with OHS, just like how you create a domain in WebLogic server, you will create a domain for OHS as well to create OHS instance, right? So there are different modes to install OHS. One is standalone mode, which works independently.
It is not like in IHS how we are creating the different conf by mentioning the just listen port and domain name in the single conf. Here we need to create a different domain.
Yes, you can create it. You can define virtual host in the httpd.conf, or else you can also use mod WL OHS. This is a module, and also there is a conf file for this module. So in this conf file, you can define different applications, uh, the location tags. Inside the location tags, you will provide with the backend application servers cluster details and also the independent hosts based on the application. So in the location tag, you will define the context route, and inside the tag, You can define all the domains and server names, whatever you want.
Okay, and in WebSphere in IHS, we
Yeah.
are just defining the key file, stat file, and the key label and the
Yeah.
SSL enabled. Okay, in the single
Yes.
same http.conf. Here, the different SSL conf will be there.
Yes. There will be
So,
ssl.conf file. Everything will be defined here.
okay, but that is a different conf file other than HTTPD, which is work only on SSL.
Yeah.
Okay.
So why this is given like ssl.conf and modwls.conf? Because it makes your work easier. You don't have to, do everything in. What happens if http.conf got corrupted, right? You will lose all these configuration also. So that is why it is separated. So your http.conf contains the references for these configuration files, right? So if you want to change only SSL configuration, you can directly access this file and do the changes. You don't have to log into HTTPD. If you want to do application level changes on OHS, you can directly log in, you can directly access this configuration file and add the context routes and do the backend application servers configuration changes in this application only. You don't have to touch httpd.conf. So only the modules or few listen addresses or port numbers that can be changed in the httpd.conf. And when you work on ssl.conf, for the listen address will be inside this ssl.conf. You can define the virtual hosts as well in ssl.conf.
Okay.
And one more thing is um, you don't create the instances from admin console like IBM WebSphere. You cannot define the IHS or the OHS instances. No, you will create a domain. And while creating a domain, you can create the Oracle HTTP server instances. And with the help of this module, it will be integrated with the WebLogic server or Oracle Fusion middleware to proxy the requests. And to manage, if you want to manage OHS instances, then you need to integrate OHS with Fusion middleware infrastructure, not WebLogic server generic installer. Okay. If you want to use the GUI to manage and monitor OHS, then you need to use Enterprise Manager, not Admin Console. There is no feature in WebLogic to manage and access your OHS instances from Admin Console of WebLogic server. Clear?
Yeah, yeah, clear.
Okay, great. So let us understand how this OHS engine works, just like Apache, because it is totally based on Apache. So the processing of requests, it works with the engine, and this engine is fueled with MPMs, multi-processing modules. So it is an Apache. Uh, Actually, this MPM in Apache controls how the server handles incoming requests. So in WebSphere, we have seen, right? Um, if you're accessing the internal URLs without any reverse proxy in the front end, how the request will be handled by your kernel, the dispatcher, right? And if there is a load balancer or a reverse proxy and your request is hit to the reverse proxy, then your Apache server uses NPMs, whatever you configured in the httpd.conf. So there are three types of NPMs supported by OHS. And you can use the MPM based on the type of application in the backend, deployed in the backend. So MPM determines how Apache creates and manages processes or threads to serve web requests efficiently. Okay, so what does this mean? For, for different applications developed using different languages or scripting languages, the request handling is done with a type of processing, different processing methods. Some applications will support processes instead of threads. There will be no threads. It requires processes. And some applications requires threads to serve the web requests. So let us understand this one. So what is MPM? It is multi-processing module in Apache and which controls Apache how the request handles, how the requests are handled by the Apache incoming requests. So in simpler terms, it determines what NPM determines how Apache creates and manages processes or threads on Apache server to serve web requests efficiently. So Apache receives an HTTP request and processes it using selected NPM. And the startup process, when Apache starts, it loads the NPM module based on httpd.conf or system configuration. And it creates the worker processes or threads based on NPMs. So why it is saying processes or threads, we will understand in a while. So it depends upon the type of selected NPM. And handling the requests, NPM controls how requests are assigned to processes or threads based on selected NPM. And it also defines how many concurrent requests Apache can handle. So you can define concurrency in the business critical environments, let us say banking environments. Concurrency has to be maintained because of high traffic. So for that kind of environment, you need to select an NPM that provides the concurrency and also the and also give you better performance and efficiency. It should not burden the Apache server and uh, the throughput as well. So yeah, logging and cleanup. After processing, the response is sent back to the client. Apache logs the request and cleans up the resources. Now, there are three MPMs. One is worker MPM, event MPM, and pre-fork MPM. What is worker MPM? It spawns a fixed number of processes. So each process creates multiple threads. We know threads are smaller processes, minute processes of a parent process, right? So each process creates multiple threads, and you can define how many processes you want. And it is good for high traffic and efficient memory usage. So we will understand why this efficient memory usage is mentioned under worker MPM in a while. And event NPM. So what is event NPM? It is similar to worker NPM, but it uses non-blocking IO. I think we have discussed this non-blocking IO. We'll discuss it once again. What exactly is non-blocking IO? that is supported by Event MPM. So the Nginx also uses the same non-blocking IO MPM, which is which is supported by Event MPM. So it is similar to Worker MPM, but uses non-blocking IO. Meaning what? Worker MPM does not use non-blocking IO. Why Event MPM is more efficient? Because it uses keep alive connections. Okay, this is another term. We'll understand it in a while. So this gives you better scalability under high load and pre-4 npm. So what is this? Is a older, and each request is handled by a separate process. There are no threads, unlike worker npm. So worker npm, you can define fixed number of processes, and each process creates multiple threads. This is good for high traffic and efficient memory usage because threads are doing all the work. These are the worker threads. But here, each request is handled by a separate process. So here, threads are not handling. Threads use very smaller memory footprint, whereas the process needs larger memory footprint. So that is why it is heavier on memory, but safe for non-threaded modules. So the MPM selection totally depends upon the type of usage and the type of environment and the type of applications. So it is not like, if this pre-fork NPM is heavier on memory, you don't use it. No, it is useful for the modules where non-thread mechanism is required. Okay, so event NPM, yeah, for non-blocking, if you want to utilize this feature, then you will go for event NPM. Provides you most efficient way for better scalability under load. Uses keep alive connections. So different MPMs optimized for various workloads. Pre-fork MPM, it is good for PHP-based and process-based applications. No threads. Only processes will do the work. Heavy lifting will be done by processes, mostly for PHP-based applications. Worker MPM, it is a thread-based, provides with better performance. It is called hybrid because it creates both processes and threads. You will define the number of processes based on your system resource. Which resource? The number of CPUs, the number of cores. If you have 4 cores, you can define 8 processes, and 8 processes will create multiple threads, and these threads will do actual processing. And event npm, it is optimized for high concurrency, uses non-blocking, better for high traffic. So in event npm, non-blocking means that Apache does not keep a thread occupied while waiting for a resource, slow client, to send and receive data. So instead, in the waiting time window, it frees up the thread to handle it frees up the thread from the old request which it is currently engaged with, and it allocates with a new request. So it frees up the thread from the current slow client or waiting or the thread which is in waiting period, and it will free up to handle new requests while monitoring slow connections in the background. So that is non-blocking IO. So this mechanism allows Apache to handle thousands of concurrent requests efficiently, making it ideal for high traffic websites, API transactions, and WebSockets, right? So this is non-blocking IO used in event NPM. The same is used in Nginx as well. So this is how it works. MPMs in OHS, pre-fork, worker, event. So pre-fork multiple processes, not threads. And worker MPM, multiple processes, but each process handles multiple threads. Here, each process handles one request at a time, no threads. Here, threads handle concurrent requests, efficient memory usage, and better concurrency. So here, more efficiency usage, but safer for non-thread safe modules. And when it comes to event NPM, it is similar to worker NPM, and it uses non-blocking IO for keep alive connections, which improves the scalability under high loads. And that optimizes and you know uh, it syncs with the modern web traffic patterns, event NPM. So this is about the key features and how the uh, core components of Apache and OHS works, and the engine that uses different multiple multi-processing modes based on backend applications, right? So in real-time installation, there are two methods. One is GUI and the other one is silent with no UI. Just you will give some command mentioning the silent flag and provide with few parameters. The sample response file will look like something like this. It will have a Oracle Home, installation type, declined security updates. So if you see the installation type, it is mentioned standalone HTTP server, and it is managed independently, meaning it is not dependent on WebLogic. So you cannot manage this standalone HTTP server from WebLogic admin console. So if this response file contain, if you change this to co-located, then it can be managed. It can be managed from WebLogic. Two type. So the directory structure, yes, this is for standalone. You will create Oracle Home independent Oracle Home, and this contains OHS domain, and your OHS domain contains a node manager and OHS component or instance. And the same for co-located, same Oracle Home for WebLogic and OHS, right? So the same node manager is registered with OHS component. So this is collocated mode. So you have to install OHS on the same machine where you installed WebLogic. So this is collocated mode. And again, collocated mode can be configured with JRF and non-JRF, restricted JRF. We'll talk about these in the next session. So OHS, the overview of the directory structure, it contains a bin where the startup scripts are placed under binaries, and the configuration will be under Fusion Middleware config, Oracle HTTP server configuration, like all these config files will be present. And it contains a component folder where OHS components are present, and diagnostic logs, access log, error log, and other diagnostic logs, libraries, libs, OHS libraries, and modules that is used by the custom OHS, the custom OHS libraries and custom modules to integrate with backend application servers and instances, instance specific files. Why instances? You may have OHS1, OHS2, OHS3 on the same server. So instance specific files can be found under instances directory. So in summary, OHS is a web tier Apache server integrated with Oracle middleware products, and key features: it provides with reverse proxy and integration with backend servers, SSL termination, and high availability. Components, yes, these all configuration files are the main components that determines how your request proxying works. Installation methods, GUI and silent. Real-time usage, yes, SSL offload, reverse proxy, and cluster load balancing. Tools, enterprise manager to manage and monitor your OHS, and also you can use WebLogic scripting tool to manage and monitor OHS components. So this is all we need to know about OHS before we get hands-on practical sessions. So once you understand how this works and what are the key features required for your environment, you can configure those accordingly. Any questions?
No, I understand fully.
Okay, fine, great. So in the next session, we'll start with a practical session, and most likely we will use most of these features with different parameters uh, defined in the configuration files. So we'll catch up in the next session. Thanks.
Yeah, yeah. Thanks, Aya.